Good morning, students. By the continuation of the previous lectures in ray optics, 12th standard Cbse. So this session we are going to discuss about the image formation by concave mirror and convex mirror. Okay, the first one what we are going to discuss is image formed by a concave mirror. What, children? Is a concave mirror. This topic we are going to explain now. Yes, it's very simple and easy, but if you know the property of the image, then only in the numerical calculations we can cross check your answer, and it's a sign convention. The values are whether it is right or wrong, whether that property, the results, the numerical values will match with the results. That means what we are getting the nature of the images. Okay. So for that purpose, this information is very important. In case of concave mirror, as you just see that, children, as this is the concave mirror, as we said in the previous lecture, this is principal axis and the pole of the mirror. This will be principal focus, and this is the center of curvature. C is equal to 2f. Okay, C is equal to what, children? 2f. Yes. In case of a concave mirror, as we said earlier, that in Cartesian sign convention, generally the real object is placed at the left side of the mirror. Okay. Now please see that there are 6 possible cases. There's one by one we are going to discuss. There are 6 possible cases where you can keep the object in front of the concave mirror. So what are all the possible positions or means? The first one is object at infinity. That means, as we said in the previous lectures, whenever the distance object is placed, we will get the parallel light rays or light beams. Okay. So object at infinity. The second one is object is at or beyond 2c. Object what, children? Beyond 2c. Beyond c. What is that, children? Object beyond c. What is the difference between this and this? Means it's very far distance, but this is the finite distance beyond c, the second position of the object. And third one is what, children? Object is at c, and the fourth position of the possible position of the object is object at or between, we can say that between f and c. And the fifth position is what, children? Object at f, and the last one, sixth one, is object is between f and p. Object between what, children? F and p. So these are the possible positions of the object. The only one simple logic I can given to you: whenever object is approaching the mirror, you just keep that point alone to write the property of the image. Whenever an object is approaching the mirror, the image will be moving away from the mirror. The first point is the logic what we must keep in mind, that is, whenever object is approaching the mirror, that means coming closer to the mirror position, and the image will be moving away from the mirror, increasing in its size. Increasing in its what, children? Size. For the cases from position 1 to 5. For the possible positions 1 to 5, that logic can be applicable. When the object is moved towards the mirror, the image will be moving away from the mirror by increasing its size. Okay, children, that concept is applicable for case number 1 to position 1 to position 5, and this is the very exceptional one. These cases we will get the common factor is what? Real images. All the images will be what, children? Real images for these possible positions. But apart from that, this will be a different one. It will produce the virtual image. In the previous lectures, we discussed what is real and virtual images. Okay, children. The first position is what, children? Is object at infinity. You just see the given diagram. The ray diagram is shown here in a slide for your reference. Whenever object is at infinity, we know that the light rays coming from a infinite distance object will be a parallel light rays. As we said earlier that there are 2 rules is enough to draw or to get the ray image formed by the mirror. So, but here you just see that and these light rays will converge at a single point. Yes, that is what, children, is the principal focus of the mirror, and this is the position of the image. Yes, so this is the image position when the object is at infinity. Object is at what, children? Infinity. That is shown in the diagram. But the property is what are means, since the object is very far, as we know that because the object is very far, the image will be highly diminished. Image will be what, children? Highly diminished. Since it is a real image, that image can be obtained on the screen. Okay, for example, you can focus the sun on the concave mirror or any distance object in your laboratory, distance tree or something, some object, building, something else, and that can be focused on the on the screen to find the approximate focal length of the concave mirror. Yes, that is the case 1. And the second case diagram is what, children? Object is beyond C, but it is a finite distance and beyond C. You just see the diagram, children. When the object is beyond C, that means from infinite distance to a finite distance the object is moved. So because of that, you just see that when the object approaches the mirror, the image will be moving away from the mirror. That's why in the object beyond C case, when the distance becomes to finite towards the mirror, the image will be shifted away from the mirror. That is, now the image will be formed between F and 2F. You just see this diagram, children. Yes, when the object is at the beyond C position, now that means the object is approaching the mirror. Now the image is moving away from the mirror. Previously it is at the point F, now it is at the point what, children? Between C and F. So it's slightly moved. At point F case, what I said, it is a highly diminished real image. Now it is slightly moved away from F, but there will be slight increase in size of the image. So therefore we can say that in case 2, that is object beyond C case, is what, children? The image will be a real image, since it is formed, all the real images will be generally formed in front of the concave mirror. So the image will be a real and a diminished image. It is a highly diminished. Now this can be said to be as a diminished image, since when compared to here, it's just like a point and it has some dimension as A dash B dash as the image. Okay, children. Yes, and go for the next slide for the next position of the object. Yes. Now please see that. The third one is what, children? Object at C. Third one is what, children? Object at C. You just see that again the object is moving towards the mirror. As I said, the image will be moving away from the mirror. That's why you just see that when the object is at C or 2F distance from the mirror, the image also shifted away from the mirror and coinciding at this position is A dash B dash. So in this position, object and images are at the same position C from the pole of the mirror. Yes. Now again, as I said, the image will be real, since the image is formed in front of the mirror. So real image is formed and the same size as that of the object. That means height of the object and height of the images are equal. Okay, children. Now you please see that another position. Okay. So that is the fourth position. Fourth position is what, children? As object is between F and C. Object between what, children? Yes, F and C. Again, as we said, again now the further the object is moving towards the mirror between C and F, that is shown here. So when the object is between C and F, the image will be moving away from the mirror. That means the image is formed beyond the mirror. And here you please don't put the dotted line, or they are shown here to distinguish the image and the object. But generally dotted line means it represents virtual image. But here, even though in diagram it is given a dotted line, yes, you can draw that as to be a solid line in order to show that it is a real image. In general, yes, the image formed in front of the mirror is generally a real image. So in this case, yes, when the object is between C and F, the image is away from the mirror, since the object approaches the mirror. So the image is formed behind or beyond the C value or beyond the 2F value by increasing its size. Since it is an inverted one, obviously it will be a real image, children. Yes, go for the next slide for the another two positions. So that is the fifth position is what? Object at F It's very inverse case of the first one. The fifth case is just inverse of the first one. So when the object is at infinity, image is at f. Now the reverse is when object is at f, image will be formed at infinity, but the size will be highly enlarged. We can say that what, children? Where we said in the first case highly diminished image, now the situation will be as reversed. Now the object is at f, now the image is formed at infinity in front of the mirror. Now it is enlarged in size, but that fifth one, as we mentioned here, it will be a special case. What is that, children? Yes, it's the virtual image. This is a special case when compared to the remaining 5 cases. When the object is placed between so therefore P and F, you just see that. Yes, as we said, very simple, no need to memorize anything, just apply any two what is that, children? Rule, what we learnt in the previous lecture. So now please keep some object, some real objects, so A and B. Now what will happen, children? You can apply any two rules, so that they are used in the as a third and a fourth rule. We can use it anything for our convenience. Okay. Now please see that whenever the light rays is passing through the center of curvature or appear to be passing through the center of curvature, as in this diagram they mention that they will retrace its path. Okay. So we can draw in any manner. So I can draw like this. Yes, after reflection it will passing through the F, and similarly when it is falling at the pole of the mirror after reflection, it makes some angle. Yes, now you just extend this reflected rays, and they will meet behind the mirror. These rays will, the reflected rays will extends backs, and they will meet at this point, and this is A dash, what, children? B dash. So object is erect, vertically upward, image also vertically upward. That's why it is called what, children? Erect image. Erect image is obviously is nothing but virtual image. So this position of the image only is used in dentist as a magnifying glass. As a what, children? As a magnifying glass. Like that is magnifying glass is for lens, but here for dentist purpose, the doctors may use to see the enlarged image of the teeth, that is by this position of the object formed by the concave mirror, children. Yes. So go to the next slide to summarize the property of the image formed by the concave mirror. Yes, children, you just see that when the image is at infinity, object is at the focus, and it is the highly diminished. Since the image is formed in front of the mirror, obviously it will be real and inverted image. Now the second one is beyond the center of curvature. As I said, when object approaches the mirror, image will moving away from the mirror, increasing in its size. So therefore between F and C, and that will be formed what, children? Diminished image, real inverted. At the center of curvature, what will happen, children? It is same at the position of the image, also at the center of the curvature, same size, real and inverted. Between C and F, yes, and the image will be beyond C, is enlarged, or images real and inverted. And at the focus, at the images at infinity, highly enlarged one. And the sixth one I can write, that is not given in the table here. For the sixth one, is the image property is what, children? Virtual image. So therefore image is what, children? Is virtual one. Yes, image is virtual, and enlarged image. Image is virtual and enlarged image. Enlarged what, children? Is image. And also, since generally anything formed behind the mirror is obviously virtual, therefore image is formed, yes, image is formed behind the mirror. Image is formed what, children? Behind the, yes, behind the mirror. Yes. So this is the, yes, the nature of the image formed by the sixth case of the, yes, concave mirror. Yes, children, please kindly note it down. Yes. Okay, so yes, the next one is the image formed by the convex mirror. Yes, please go to the next slide. Yeah, yes, now please see that as we discussed yes, in the concave mirror cases, the 6 possible position of the object. Here also in convex mirror also the 6 possible position of the object is possible, but since their properties is the same for most of the cases, that's why here we generalize has to be only 2 positions of the object. The first one is what, children? Yes, when object is at infinity. When object is what children? Infinite distance. That is as we said, infinite distance, object at infinity. We know that when the object is at infinity, image will be formed at principal focus of the mirror. Since we just see that it is a convex mirror where the reflecting surface is curved outward, as this is your principal axis and P, some distance object. We know that the distance object produces what is that, children? Parallel beams of light ray. So therefore after reflection it is appear to be, as I said, the virtual images are formed behind the mirror. So you just extend these reflected as light rays and they will meet behind, they appear to be meet behind the mirror, and this is the position of the image formed by the convex mirror. Yes, since it is behind the mirror we cannot obtain on the screen, so therefore the nature of the image is what, children? Is a highly diminished virtual erect image. Highly diminished virtual what, children? Erect image. Yes, that is shown in the diagram. Okay, yes. Now you please see the second case. Yes, the same slide it is shown. When the object is placed between the distance f and yes, p. Yes, we can or not only f and p, or it's general, any general, yes, object lies. This is at infinite distance. It is any finite distance. Object at any finite distance. Any finite what, children? Distance. Say for example, yes, beyond C. Yes, yes. You just see that these are the distances only. Say this is for example 10 centimeter, means we can say from yes, before the principal axis this may be the 10 centimeter and 20 centimeter, 30 centimeter, 40 centimeter, like that we can show. Yes. So in that cases when the object is placed at finite distance, here in slide I mentioned that when the object is between f and p, is not only from f and yes, between f and p, it can be for any position as we mentioned in the case of as a concave mirror. Yes. So in that cases the image will be formed yes, only between f and p, children. Yes, that is the main difference between the convex mirror and concave mirror. Yes, yes. Sir, how, sir, for a concave mirror f and c are marked in right side, but you are telling that you can keep the object at any finite distance like beyond C, at C, between f and c, like that. How it is possible, sir? Means I am just taking the distance alone. For example, the focal length of the convex mirror has to be 10 centimeter, means in front of the mirror I can mark this has to be 10 centimeter. So this distance I can approximate as to be the position of the object f, or we know that r equal to 2f we are going to discuss, so we already yes know that. So this is a 2f value, that is a 20 centimeter. From there to here I can mark that has to be 20 centimeter. If I am keeping the object here, I can say that the object at C. If you are keeping here object at yes, f, or we can see here between f and c, like that. Yes, even though the c and f are defined for the convex mirror in the right side, because the imaginary sphere will be formed part of this yes, reflecting surface in right side. That distance, for analogy I can take the distance has to be as position of the f object at f, object at yes, c, object beyond c, whatever may be these finite positions, the image will be always formed, whatever may be that. For this case image will be always formed, always what, children? Formed yes, between f and p, between what, children? F and p. In slide I mentioned only yes, I just taken as example for only one position of the object, but this is true for any cases when object is beyond c or at c, between f and c, or between p and f, or at f, whatever may be that, the property of the image is remains the same. So for example, you just consider that diagram. So I can place this object AB at S beyond C or somewhere, yes, any is a finite distance as we marked here. Originally f and C will be exist in right side or marked in right side. For to show the positions of the object, I just marked as to be f and C in the left side, just for convenient representation of these distances. Okay, yes children, now I am placing the object. You apply any two rules. If any ray is parallel to the principal axis, after reflection it will be appear to be. Yes, that is the word or differs from the concave mirror. That there actually the rays can passing through that, but here it is appear to be. Yes, appear to be. There actually here appear to be coming from the what are passing through the, yes, what is that children? Principal focus of the mirror. And take the, yes, the fourth rule what we mentioned here. Yes, so it makes some angle I by the law of reflection. This angle also, angle of reflection I is equal to R. Yes, now again you just extend this, yes, reflected light ray in back side, and they will intersect at this point. This is what children? A dash, B dash. Okay, so wherever you are keeping the object, either at a distance of F or at a distance of yes, C or beyond C, wherever you are keeping the real object in front of the concave mirror, for these positions the image will be formed only between P and F. Between what children? P and F, behind the mirror. Since it is behind the mirror, obviously the image will be what children? Yes, virtual image. Virtual image. As we just compare this size of the, yes, object and the image, obviously we can say that they are diminished to one. They are what children? Diminished, yes, virtual image. And virtual means upright, erect image also. Okay children, yes. Suppose what will happen, sir, if I am keeping the real object beyond C. Now I am moving the object towards the mirror. Since I said one statement earlier that whenever object approaching the mirror, the image will moving away from the mirror by increasing in size in the case of concave mirror. So here also, when this object is approaching towards the mirror, the image also is, in this case, image will be, the size of the image will be slightly increases, but they are lying what children? Between P and F. Even though the object is approaches the, yes, mirror, the size of the image will be slightly increased, but you just see that the position of the object, image will be remains between P and F. So this is the information about what children? As a convex mirror. The summary of the property of the, yes, these images formed by the convex mirror is shown in the next slide. As you just see that children. Yes, yeah. So yes, this is the property of the images formed by the, yes, what children? A convex mirror. The first case is object at infinity. This is between infinity and the pole. That's why I mentioned here it has to be object at any finite distance. Object at what children? Yes, any finite distance, that may be beyond C, at C, between C and F, at F, like that. Okay children, in that cases, yes. So these are the details about image formed by the, yes, what children? Yes, a convex mirror and a concave mirror. The plane mirror concept is not there for Cbse point of view. But when we discuss the MCQ or numericals, at that time I can revise the property of the image formed by the plane mirror. But in lower standards, you may study the plane mirror as what is that children? Yes, image property. Yes, it's very simple. So if you want, I can yes, we can write also image formed by what children? Plane mirror. So image formed by, yes, a plane mirror children. Yes, just to give you the very brief outline about Cbse point of view, but it's not necessary. But MCQ in detail we can discuss that one in numerical discussion session. Okay, image formed by the plane mirror. The first one is what children? Yes, this is the plane mirror. Yeah, yes. If you are keeping the any object, let us consider this is your principal axis, and any real object is placed left side of the as a plane mirror, and you just see that this is the normal incident, it will reflected back, and just see that this is the reflected image, reflected rays. Just extend the, how to get images are, you just extend the what is that, or makes the contact with the reflected rays, it will gives the image. You just extend this line children. Yes. So this is A dash B dash. Behind the mirror, obviously it will be what children? Virtual, and the size of the image and object will be same. Let HI, height of the image is same as to be height of the object. Since it is forming behind the mirror, so the image will be what children? Virtual image behind the mirror. Since they are having same height, their distances also, say this is object distance U and this will be image distance V. So magnitude wise, sign will be different, but the magnitude wise this will be U and this will be U. So that mod V is equal to mod U. Object, the magnitude of the image distance and the object distance are same, and their magnification value is what children? +1. Because M is equal to V by U, no? So they are same in magnitude, so we will get a +1. Since it is a virtual image, the sign of the magnification is positive sign. Real means negative will come. Okay children. And since one V is equal to U, therefore we can say that the focal length of this plane mirror will be what children? The fourth property I can write here. The focal length of the plane mirror is infinity. Focal length of the plane mirror is what children? Infinity. Okay. And another fifth one is we know that the image will be laterally inverted. Image is what children? Laterally inverted. Laterally what children? Inverted. You know that in lower standard you may studied that why the in ambulance why that word is written in a reverse manner means, since when it is viewed from the rear view mirror or convex mirror from the moving vehicle, the image gets laterally inverted. So these are the very brief explanation about, very short explanation about image found by the plane mirror. But this is not as necessary or that much important for Cbse point of view. But the numerical solving and MCQ purpose, obviously elaborately we will discuss that. And these lectures only for Cbse point of view. So you just make a note on these children. Yes. Thank you.